Hi, everyone. You can come in. There are some free chairs here. Please, come in. Great. So welcome, everyone. My name is Dimitra Petrova, and I'm part of VMware. So during my career, I have taken multiple roles in the data space, starting from advanced data analytics and predictive analytics. Then I switched to data engineering, as well as data analytics. They usually go together. And now I'm just manager for a team of data analysts. Yeah, things go like that. And I have the pleasure to introduce you Antoni Ivanov.
That's me. Nice to meet you.
Who's also part of VMware. And he's actually the lead maintainer of an open source project, which is called Versatile Data Kit, which is a framework for data engineers that I'm going to talk about later in the presentation. But also Antoni is part of a team who is providing us with a central data analytics platform, end-to-end data analytics platform in VMware. So actually, I'm the user. Antoni is the person who provides us with the infrastructure, and we work a lot together. And we actually have a lot of talks about problems that we need to solve for my team and other teams like us in the company. His team is actually very responsive in trying to find the best solutions for our use cases. So I'd like to start with a story. I mentioned that I used to be individual contributor, so actually doing some work. And as every regular employee, I'll go for a PTO. So one Christmas, I went for a long PTO, like 3 weeks. You can imagine, like food, drinks, world is good. And one day, one of my colleagues actually called me with a problem. So one of our reports that used to be looked by the CEO stopped projecting the most recent data. You can imagine the problem. So what happened is that no one in the team could figure out why. They couldn't find what the reason was. They tried to debug it. They couldn't. So they actually called me for some help. So, the holiday was ruined. All the team was, back on solving the task and trying to figure out why this actually happened. So let me first explain to you why they actually called me and what was the reason why they couldn't actually figure it out without me and what was my role there. But before I explain what was my role, I need to give you the picture about the setup that we used to work in. So we had team one, who was actually extracting some data from Salesforce. And they had an ingestion code running, written in Python, running in a virtual machine hosted somewhere. And they were pulling that data from Salesforce into a database. My team was the second team, actually used this data and merged it with other data sets, and actually produce our report for the CEO. And why was it so hard for us to figure out what was the problem? Well, when you have different teams that are collaborating and contributing different data sets, it's actually very hard, or it used to be very hard for us, to track downstream what was the problem that manifested for us. So we have to think about, how you debug, how you have a data visibility from the very beginning, the data enters into the system, to the very end when the data actually goes out for reporting, machine learning, you name it. So one of the reasons why this report actually failed was that Salesforce changed the type of one of the columns from numeric to string, and hence our ingestion got broke. But nobody understood that, because the team had some ingestion pipeline. They probably didn't care about monitoring and having notifications if things go wrong. And someone downstream had to let them know that something broke so they can go and fix it. This sounds like a super trivial problem we all have to deal with. And you can consider that those problems should be resolved like a minute or an hour. Well, it didn't used to be like that for us. So let me tell you how we actually solved that problem for our company. What you typically have is, in a big company like VMware, we typically have like numerous of data sources like ERMs, CRPs, probably some websites, telemetry coming from the product. The list goes on. And the first thing you have is you actually, to make sense of this data, you actually need to bring it into a common system so you can start running queries, machine learning models, clean the data sets, etc. And different teams get to extract different data sets. So, you're probably familiar with different tools, like how many of you probably use Python to do ingestion jobs or bring data from third-party systems? Okay, I see a couple of hands. Maybe some of you use Informatica. You can raise your hand if you do. No? Okay. But full story or something like that, you probably have heard of some of those. So you actually introduce some tools that do that ingestion. And then the next thing is, okay, your data set is there, but over time the data grows and you actually need some automation to do all the processing and actually move that raw data into something that's more business related. And that's where the data transformation tools come in place. Probably you've used DBT labs. You can raise your hand if you did, like stored procedures in SQL to do such kind of things. Some hands. Okay, I see a couple of hands. So what happened is that you just introduce even more tools to do your job. So essentially what you end up with is fragmented infrastructure. So you create some silos along the process, along the data flow into your system. And at that point, debugging how the data has changed, where it changed, probably where it actually didn't go very well, is very, very hard to debug. And especially if you have multiple teams that are running different instances of those tools for their particular team, this actually becomes a real nightmare. Not only from infrastructure point of view, but also from the point of us, like data engineers and data analysts, to go and find and chase how this data came in. So today we are going to talk about how are we going to solve this problem and come up with a unified place where all of your data workflows, regardless of whether they are ingestion, transformation, maybe export to some third-party systems, ML tools, whatever, can be considered as a combined environment. So I've already stated some of the problems. I must say that we, as data teams, we don't care whether our infrastructure is fragmented or not. What we care is, however, do we have the visibility where this data came? How was it transformed? Did it came in its raw format, or did it have some initial preprocessing before it entered the system? And this is especially important if you are running some predictive analytics that goes back to your products, which is something that we had. So actually having that visibility was very, very important for us. Debugging as well. This is, probably 40% of the time that we spend during the day to actually debug stuff and fix them. And probably one of the biggest priority for data teams is we need to deliver our metrics and our reports quickly because our business wants them very, very quickly, and they want them with a good accuracy. So actually, we need to be very confident in what are the metrics that we are producing. So how we solve that for VMware? Well, our infrastructure team has created a data engineering framework for us that essentially unifies and abstracts the whole infrastructure, while you can actually have a central place where all of your data workflows sit together. And it's also a collaborative environment. What do you mean by that? Well, this is a place that allows you to have a multi-tenancy, so essentially have different teams that work with the same team, but they still have that isolation and control that only this particular team can change those, we call it data jobs, data workflows, you can call it as you wish, that do different parts of that transformation, bringing data, exporting data. And actually, we as data teams want that to be self-service because we don't want to create dependencies on other teams as I showed previously. And also, we want to be able to put our code in production by our own, without needing to depend on any other team. So this is what we are going to talk about today. One important thing, though, is this framework. By the way, this framework is now open source, so all of us can Google it. Is a tool, right? It's just a tool, but it actually needs to solve for our problem. There is one more important thing that we need to change as a mindset in order to make sure that this tool set is working correctly. And this is thinking about the data as a product, not just some table that we create or some model that we create. It's more than that. It's actually a product, which means that we need to treat the data and the data sets that we produce as a product and live up to those standards with clear SLAs, with clear information on refresh cycles, meaning of that data, where that data came from, so essentially give that visibility, as well as, of course, monitor, alert ourselves if something goes wrong down the whole path. So, after all, our talk is about DataOps. So, what does this have to do with the problem that I stated? Well, first of all, let me acknowledge the two personas that we have here. So on the one side, we typically do not create databases on our own. We actually have to work in collaboration with infrastructure teams. So we need to acknowledge that part of the data providers or the data infrastructure providers. And on the other hand, it's us. It's actually multiple teams of data people, like machine learning teams and data science teams, data engineering, data analytics teams. In different companies, it's actually structured a bit differently. So the goal of the infrastructure teams is essentially ensuring our databases and tools are available and are secure and are reliable so we can use them. While we have little different goals. We actually keep the domain knowledge. We know what the data means. We know how to transform it. We implement the business logic, and we actually need to optimize for agility and speed so we can provide what our stakeholders, essentially the business, wants. So we can see those can be very contradictory goals for those two teams. And this was a problem probably 10 years back between software engineers that stayed at the side of the data teams and the infrastructure teams. And they actually solved it. And how they solved it? Well, they created the DevOps cycle for them. So they actually came up with a set of good practices that allowed them to actually make sure that software engineers are effective and also infrastructure teams do not suffer. So we can use those practices from the DevOps into the data world and really start treating the data as a product. Why do you see the different colorings? Well, because we at data teams, we typically care about planning. What we want to do is essentially the requirements understanding. Coding, it can be SQL, it can be Python, it can be something more. And monitor that our processes work well. The rest should be taken care by the tools we use, the infrastructure teams that provide us with those tools. We probably do it sometimes now, purely because the tools that we work with kind of require it. But this is not what we are good at as data teams. We are good at actually making different uses of the data and transforming those metrics into something that's more business related. So what we need to ensure that we as data teams are self-service, we are provided with a managed infrastructure, so we don't need to care about it. And it's automated. So whatever we do and produce in terms of transformations, machine learning models, bringing data is actually in production. And we can put it there by ourselves. At the same time, not sacrificing what infrastructure provider teams care about. And at the same time, ensure that we have an environment where we can successfully collaborate with different data teams. This is actually very valid for data analytics in companies of big scale where we have multiple teams, and I just want to make that disclaimer as well. So what Versatile Data Kit actually is, well, it has two components. One is the VDK SDK, which is something that you can consider it like a Python library that you can install on your local computer, and it provides you the ability to run data jobs with SQL, Python, the combination of both, you name it, where you can use like all the normal Python libraries that you would typically use. But it also provides you with data lineage, data quality plugins that you can add to your data workloads. And it also has a control service, which is typically managed by the infrastructure. And this is the place that with one line, we actually push our code to production. We don't manage it. This is managed by the infrastructure, but we use it to put our data jobs in production. So basically, this is the runtime. This is where things happen on a schedule. And it also provides us one very important thing, which is monitoring and alerting. So if something goes wrong, we know that it actually went wrong. I wanted to do like a bit of a more extensive demo, but due to time constraints, this wasn't possible. Okay, but I have prepared a slide that hopefully would signify what I want to show you here. So Versatile Data Kit provides data lineage capabilities, which essentially show you how your data has entered into the system, has been transformed, what are the output tables. So essentially, the whole end-to-end process till the moment that data goes out of that system, because sometimes it might. So you can consider SQL, Python, any standard interface, maybe PyTorch, PySpark, TensorFlow, you can name probably a lot more than that. So what VDK does is it actually detects automatically all of those interfaces, and it captures the data movement, stores them in a database, so you can actually have a whole data lineage. This is a very simplistic use case, but it actually tells you how the data enters, how it's being transformed, and what is the table or the tables where this data has been used afterwards. And you can imagine if you have more data pipelines, this would kind of scale. So this is actually quite important for us as data engineers to know how our data has been transformed, so you have that full end-to-end data traceability. So what does this tool provided for me, for my team, as a feature set? You can actually have a look at it here. I'm not going to go through all of those features. The one thing that I mentioned was the multi-tenancy. Right now, what we can do is, if I want to see how a data set was produced, I can find that set, and I can see all the processes beforehand that bring that data, that transform it. I can look into those SQL codes or Python codes, and I can review them. Not edit them if I don't know them, but I can see them, and this is powerful. Also, there is support for dimensional modeling. So if you are a data engineer and you need to make sure that your tables are arranged correctly, optimally, there is some out-of-the-box capabilities there. And also alerting and monitoring that comes out of the box. So whenever you deploy your data workflows on the control service that I mentioned, that was the second component, you actually start to get notifications if thing goes well, if thing goes wrong. You can put them even on Slack if you're using Slack. So you actually have that capability to really operationalize and productionize your data workflows. One thing that we don't have at the moment is web UI. However, our infrastructure team is heavily working towards outsourcing this bit as well, hopefully soon. But yeah, this is something that's expected to happen in the next couple of months. So that will even improve the things from monitoring and managing standpoint. So I want to go back to the initial story and kind of end up with how the picture has changed for my team. So before, we really had like a barrier between those two teams and no visibility of what the other team was doing. But whenever those processes are deployed into Versatile Data Kit, what you have is actually one data pipeline running that has been contributed by Team 1. I can see it as a team. I can see whether it was successful. I can see when was the last run. And then I can actually use that data and have the tools to actually debug and understand what's going on. So this was quite a powerful change for our team. Okay. So you can search for Versatile Data Kit on the internet, GitHub, Slack, Medium, YouTube, whatever probably suits you, wherever you are. We are currently collaborating with other data teams to kind of come up with more features, more use cases, better understanding of how else we can improve those processes and how can we actually make those DataOps strategies even better. So you can check it out. And yeah, feel free to reach out to us if you would like to become a partner in coming up with those use cases. You can probably raise an issue on Git, or you can just contact us afterwards. So yeah, thank you everyone. So do you have any questions?
I'm here for the questions mainly, if there are any
Great.
questions.
Okay, Anthony says he's here for the questions, so don't be shocked of him not saying anything.
I think there is
We have the first one.
Hello. Thank you, by the way, great talk. I have one question. You mentioned a couple of times data as a product, which I think is a data mesh concept. Can this tool be used to implement a data mesh in the organization?
Yeah, I can answer that.
Yay!
So I'm working in our analytics platform for 9 years. In our analytics platform, actually, we have like hundreds of different dev data teams cooperating together. So we had to implement our version of data mesh, which is very similar to one that's popularized by the Mac. If you go to data mesh, I think it has 2 of the principles, for example, like shared ownership, like domain-oriented ownership, and self-service data infrastructure platform. I think VDK is a building block for us for this, especially for the pieces that you want to manage data jobs in the self-service data infrastructure. VDK is self-service data job platform, and it provides a lot of utilities to be able to have this domain-oriented ownership, the concept of owning different jobs and data sets to each team and how they can be shared together. So yeah, I think it's a building block for data mesh.
Okay, thank you.
We only have time for another one, if there are still some questions. If not, you can find Dimitra and Antoni outside during the lunch break. Thank you, guys.
Thank you.
Thank you.